Hey everybody, and welcome to the final video for this chapter. So we're talking a little bit about face perception, and face perception is handled differently than other objects. But you already knew that, right? Because I told you in the first video for this chapter. So faces are not considered to be the same thing as objects. They're classified differently. We perceive them differently than we do other objects. So this leads to a double dissociation, like I mentioned. In other words, you can damage one part of your brain and not be able to recognize common objects, but still recognize your family's faces, your friends' faces, celebrities' faces, whatever. You'd still be able to recognize people, but you couldn't recognize, I don't know, a dragon, a wizarding hat, a keyboard, a phone, a car. You wouldn't be able to recognize any of those things because they're not faces. So that's called visual agnosia. We talked about that already. But there's also something called prosopagnosia. And so this is the other video that I was referring to that's at the very beginning of the PowerPoint slides. Prosopagnosia is whenever you basically can see everything except for somebody's face. You have the inability to recognize someone's face because you can't put together those parts. You can't put together those components. So you just don't recognize people. And that's whenever a separate area of the brain has been damaged. So not the inferotemporal cortex, but a separate one, which is also located in the ventral stream of information. All right, so here is an example, and this may work better in your PowerPoints because my big dumb head might cover up these big dumb heads. So if I were to ask you which of these pictures has been doctored and which of them is fine, which of them is the original, oftentimes people have to look at it for a second and then they can decide. It takes a little while though. It takes a couple of seconds. It's not immediate. It doesn't stick out to us immediately. But if I were to take these heads and to make them basically where we see every other face, we see that there's something horribly wrong, right? We see that there is something that looks like a science experiment, right? Because these eyes are there's clearly something wrong with them. What is it? Basically, they've been rotated upside down. And the same for this mouth. We recognize that as being incredibly wrong. But if we were to go back, we don't really see that all that much, right? It's not as immediately apparent as whenever it is right side up. All right, so I'm showing you this image because in your textbook you actually have an older image. It's the same guy. This is the guy. This is Jeremy Wolf. This is the guy who wrote the textbook. You can see him here, and you can see him again here, where he's pulling the same stunt, only this time it's somehow a little bit scarier, right? Because the eyes are angled up in certain ways. All right, so. So face perception, basically we're seeing this and we're noticing that something is wrong mostly whenever the face is facing straight up and down. So this is the job of the fusiform face area. This is a part of the brain that is going to be responsible for processing faces. Sometimes you'll hear it called the fusiform gyrus too. So this area of the brain is like the inferotemporal cortex where it helps us process objects. In this case, the objects are faces and almost exclusively faces. Not always, but most times. And if you're to scan anybody, and this is like one of the most common findings in all of neuroimaging research, if you were to look at someone's brain while they're looking at any face, even if they don't consciously recognize that there's a face there, you're going to find the fusiform face area to be active, which tells us that there's something about face processing that is almost automatic. So that leads us to a question which I like to pose in the classroom, which is, does this mean that our brains are kind of biologically wired to detect faces? And most times people will say yes, right? That there's good evolutionary reasons for that to be the case. That if we think of faces, that it's good for us to know where faces are in our environment because they can be our parents, or they could be a friend, or they could be an enemy. We need to be able to detect those things very quickly. But I'm going to show you some research that kind of suggests that actually may not be exactly what fusiform face area does exclusively. So the fusiform face area, as recently as like 1999, has been suspected that it might not be just for faces. And so Dr. Isabelle Gauthier and her research lab basically decided to test this. And so what they did is they tested people whenever they were looking at faces, but also whenever they were looking at things that they have a lot of experience with. Because Gauthier, what her hypothesis was not that the fusiform face area is just for processing faces, but it's for processing things that we have lots of familiarity with. And so what she did is basically showed these images to people who are car experts, who are bird experts, and looked to see what areas of their brain lit up whenever they looked at faces, but also whenever they looked at cars and birds. So let me show you that data. So here, this is the original data that they showed in their paper. So we see right here in this row is going to be car experts. Here in this row is going to be bird experts. So we're looking at two groups of people, car experts and bird experts. And I think the way they classify with that is that they had to have spent 10 years either working on cars or being bird watchers. So they have years of experience doing this. So this first figure, what you're looking at is faces versus objects. So you're looking at the parts of the brain that are responding exclusively to faces. So not just visual objects, but only to faces when compared to visual objects. So here we see that there is activation here and activation here. Okay, awesome. Now, here's where it gets interesting, because this is exactly what we would have expected. Whenever we show them cars versus regular objects, the area of the brain that is exclusively active whenever they're looking at cars is what you're seeing here. For the car experts, we have that same area light up, but not for bird experts. It is completely missing for bird experts. And whenever we look at birds versus objects, we see the exact opposite. So here, for car experts, we see that area that was active whenever they were looking at faces is no longer active. But whenever we look at bird experts, we see that, yes, it is active, right? And so what this tells us is that, it tells us several things, right? It tells us partly that, yes, faces do seem to elicit activation in the fusiform face area. But it also tells us that for people that are car experts, that they seem to be processing it very similarly to how they would process a face. And for bird experts, that they seem to be processing birds in a manner very similar to how they process faces. And so it's not just that cars universally elicit the fusiform face area, because we see that bird experts don't have that. Instead, it seems to have something to do with our expertise, that we seem to be experts in detecting cars and discriminating cars and telling which car is which, just like we are experts at faces. You can tell the difference between your friend and your other friend, or your face versus your mom's face, because we are kind of experts at these things. Or at least that's Gauthier's hypothesis, is that we've developed an expertise for this. Here are other figures that basically just show you in a much more boring way what I just showed you in that first image, but basically shows the difference in signal activation in the brain when comparing birds and faces for the fusiform face area in the right and left hemispheres. Okay, so the next project that this research team did was looked at they tried to address one of the main problems of that past article. The biggest problem with that past article is that it's impossible to say whether or not people, if you've taken research methods, you know about this, right? You have to randomly assign groups, because otherwise it's impossible to tell, maybe this person is an expert bird watcher because they're so good at bird watching, and that's why they got into it. Maybe this person is really good at cars and working on cars because they process it like faces. So it's a kind of a chicken and the egg thing. Is it the case that they process these items like faces because they have all this extensive experience with these items, or is it that they have because they detect them differently than other people, they have lots of extensive experience? So it's hard to know which comes first. So this research team decided to test that, and the way they did that is by creating a stimulus class that was totally novel, that nobody would have any experience with. So in this memory test, okay, here is what's called a greeble. It's a kind of a random object that this research team made. Was this the one that I just showed you? You'd probably say yes, right? Cool. If you did, you're right. This is the same one. Is this the same one? Have you seen this one yet? Or this one? 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 Gets kind of tricky, right? Because on one hand, they all look kind of different, but they all kind of look the same. And so they created several of these different kinds of greebles, and they gave them different names. So here we got Doral, right? And these are completely arbitrary. They don't really mean anything. So for some people, they told them this is a Doral. But for another group of people, they told people, oh, this is an Enoch. They just basically just wanted to make sure that that these specific names weren't, that they were truly arbitrary, that they didn't have, what am I trying to say? That these words didn't have a special connection pre-existing to training on these. So what this research team did is they basically had students come in, they had them train up on learning these different objects and discriminating them, and so then they would be able to test whether or not experience and expertise and training actually affects the fusiform face area, instead of, that you're born with a predisposition to notice cars versus birds and vice versa. All right, so they basically train them up on this new field called greebles, which you see here. Sorry, my dog howled. I don't know if you heard that. So these greebles, they trained them up, and they looked at their brain beforehand. They looked at their brain afterwards. So what you're looking at here is for people that didn't have training yet, that when they looked at faces versus common objects, they have that same area, the fusiform face area is activated, but not for these greebles, not for these brand new unfamiliar items. But after several days of practice, basically, again, we have people that is active whenever they're looking at faces. Not surprising. But what is surprising is that just after a few days of practice, we see that these people are now responding just a little bit to these greebles in the fusiform face area. And so what that means, taking this study with the previous study, what this tells us is that for these students, that just training up on learning and classifying these greebles tells us about what the fusiform face area does, that activation changes over time. That here, on one hand, they're looking at greebles and they're not seeing any kind of activation here, but after training, they are. So this part of the brain was responsible for one thing, now it's responsible for something else as well. Let's learn to process these things as well. All right, so I know that's a lot of data to unpack, but basically the whole take-home message here is that the fusiform face area is kind of named a little bit incorrectly, because yes, it does help us perceive faces, but that's primarily because we have so much experience detecting faces and recognizing faces. When we are talking about things that we have a lot of experience with, whether it be faces, or for car experts, cars, or for greeble experts, greebles, that what happens is that fusiform face area helps us process that stimulus class. It helps us process those things so that we can become better at discriminating and recognizing those specific kinds of objects. And again, it's not going to be for every object. It's only going to be for those you have lots of experience with. All right, so that's all I want to talk about for this video. I'll catch you later. Bye.